Howdy. Magma on Mars is likely. October 29th, 2022. Yes, it's 2022 and not 2021, like I said yesterday. Color-colored topographic view shows the relative heights of features in Cerberus fossae. Reds and whites are relatively higher than blues and purples. The image is based on a digital terrain model of the region from which the topography of the landscape can be derived. Since 2018, when the NASA InSight mission deployed the SAES seismometer on the surface of Mars, seismologists and geophysicists at ETH Zurich have been listening to the seismic pings of more than 1,300 Mars quakes. Again and again, the researchers registered small and larger Mars quakes. A detailed analysis of the quake's location and spectral character brought a surprise. With epicenters originating in the vicinity of the Cerberus fossae, a region consisting of a series of rifts or graben, these quakes tell a new story. A story that suggests volcanism still plays an active role in shaping the Martian surface. Mars shows signs of life and youth. An international team of researchers led by ETH Zurich analyzed a cluster of more than 20 recent Mars quakes that originated in the Cerberus fossae graben system. From the seismic data, scientists concluded that the low-frequency quakes indicate a potentially warm source that could be explained by present-day molten lava, i.e. magma at that depth and volcanic activity on Mars. Specifically, they found that the quakes are located most in the innermost part of the Cerberus fossae. When they compared seismic data with observational images of the same area, they also discovered darker deposits of dust not only in the dominant direction of the wind, but in multiple directions surrounding the Cerberus fossae mantling unit. The darker shade of the dust signifies geological evidence of more recent volcanic activity, perhaps within the past 50,000 years. Relatively young in geological terms. Explains Simon Steiler, the lead author of the paper, which has now been published in the journal Nature. Steiler and senior scientists working in the seismology and geodynamics group led by Professor Domenico Giardini at the Institute of Geophysics at ETH Zurich. Eidgenössische Technische Hochschule. Why study the terrestrial neighbor? Exploring Earth's planetary neighbors is no easy task. Mars is the only planet other than Earth in which scientists have ground-based rovers, landers, and now even drones that transmit data. All other planetary exploration so far has relied on orbital imagery. InSight's SAES is the most sensitive seismometer ever installed on another planet. Now maybe it's the only one as well, I don't know. Says Domenico Giardini. It affords geophysicists and seismologists an opportunity to work with current data showing what is happening on Mars today, both on the surface and in its interior. The seismic data, along with orbital images, ensures a greater degree of confidence for scientific inferences. One of our nearest terrestrial neighbors, Mars, is important for understanding similar geological processes on Earth. The red planet is the only one we know of so far that has a core composition of iron, nickel, and sulfur that might have once supported a magnetic field. Topographical evidence also indicates that Mars once held vast expanses of water and possibly a denser atmosphere. Even today, scientists have learned that frozen water, although possibly mostly dry ice, still exists on its polar caps. While there is much more to learn, the evidence of potential magma on Mars is intriguing Anna Mittelholz, postdoctoral fellow at ETH Zurich and Harvard University. Last remnants of geophysical life. Looking at images of the vast, dry, dusty Martian landscape, it is difficult to imagine that about 3.6 billion years ago, Mars was very much alive, at least in geophysical sense. In a geophysical sense. It spewed volcanic debris for a long enough time to give rise to Tharsis Montes region, the largest volcanic system in our solar system, and the Olympus Mons, a volcano nearly 3 times the elevation of Mount Everest. The quakes coming from the nearby Cerberus fossae, named for a creature from Greek mythology, known as the Hellhound of Hades that guards the underworld, suggests that Mars is not quite dead. Here, the weight of the volcanic region is sinking and forming parallel graben or rifts that pull the crust of Mars apart, much like the cracks that appear on top of a cake while it's baking. According to Stahler, it is possible that we are seeing are the last remnants of this once active volcanic region, or that the magma is right now moving eastward to the next location of eruption. This study involved scientists from ETH Zurich, Harvard University, Nantes University, SNRS Paris, the German Aerospace Center in Berlin, and Caltech. Yeah, ETH, some days ago, I got an answer from them. Thank you for your message. What you write seems plausible to me. That said, I would not claim to be an expert in environmental chemistry or ice core contents. The Swiss group with the most expertise on these matters is without doubt the analytical chemistry group at the Paul Scherrer Institute. Best regards and good luck with the topic. Good luck. Good luck. ETH Zurich. I just want to throw in something else about Mars. Symbols of an Alien Sky, Episode 2, the lightning-scarred planet Mars. For those who haven't seen that, watch it. And then make up your mind. This entire region resembles nothing so much as an area sapped by a powerful electric arc advancing unsteadily across the surface. Ralph Jurgens.
With the benefit of more recent data, electrical theorist Wallace Thornhill returned to this extraordinary possibility. Yes, the electric hypothesis will unnerve many scientists, but it is the only hypothesis that meets the test of direct observation. Here is a scar left by an electric arc on a piece of wet wood. Electric discharge provides a direct and complete explanation for the Valles Marineris. The so-called tributaries of the valley were cut by secondary streamers of the discharge. That is a typical signature of an electric arc when it cuts a surface channel. And here is the scar from electric discharge to an insulator. Notice in particular the network of secondary streamers to the left. A perfect counterpart to the western edge of Valles Marineris. It was long held that this remarkable region on Mars was the result of uplift, fracturing, and spreading. And from a distance, it did look like fracturing. With the closer view in front of us, it is simply irrational to cling to that interpretation. Material has been cleanly removed, exactly as in the discharging to the insulator. The evidence now available demands a new perspective, a larger field of view. In Thornhill's interpretation, the discharge took the form of a plasmoid, not unlike the plasmoid from which a spiral galaxy is formed. On his website, Thornhill noted how the discharge effect spiraled upward to the east and downward to the west, an effect that shows up quite clearly on the elevation map given on his website. In fact, if we extend the view of the elevation map, we see an even larger effect. It seems that the spiraling trails to the east and west nearly completed 2 circles as they swung back toward the trench itself. But one difference between the northern and the southern extension stands out. The northern extension is entirely constituted of ravines and depressions, while the southern extension consists of ridges and mountainous terrain. For this unusual contrast, electrical experiments offer a startling explanation. It was George Christoph Lichtenberg who in the 18th century first showed that electric arcs create ravine networks on more negatively charged surfaces and elevated ridges on more positively charged surfaces. Could it be that simple? That a cosmic thunderbolt carving Valles Marineris acted on 2 regions of different charge, negative to the north and positive to the south?
Yes, because I have to. The similarities are in a way striking. Let's just take this basic shape here. And let me show you once again the surface conductivity anomaly map of Scandinavia, where we have the plasma rocks and many other interesting things. And it has in a way a similar shape like the Valles Marineris. I just think it resembles similar features. And as speaking of features and surface conductivity anomalies, there has been a storm like here, or it was like heavily windy here since last night. And these surface conductivity anomalies, they will more and more and more influence regional weather patterns due to Earth's weakening magnetic field. We have an interplanetary dust cloud coming in. We have changes on almost all planets. I'm not sure if Venus is confirmed now. There has been Neptune's atmosphere collapsed and many other things happened. Earth is changing too. We have droughts. They are reporting all the time about droughts, but they don't report about flooding events. There is so much flooding going on, no one is talking about. They are just talking about the drought or whatever stuff they find which could scare people off. And now Mars, they detected quakes and stuff like that. Yeah, like our whole solar system gets juiced up at the moment. There is dust coming in. If you have a flame and you have, let's take wood dust. If you have just saw with a handsaw or something and you have this wooden dust and you blow it into a flame, it might just ignite. Our sun is basically a flame in space, and what happens if you blow dust onto it? Yeah. It's basically very simple to think about that. Dust explosions are very dangerous. Everybody knows that. So, I am still waiting for any answer. I was very surprised and very pleased, and it was very cool to get this kind of answer from Switzerland, from the ETH. It was my second attempt to get some answers, because I don't know, I'm uneducated, that's why I have so many questions. That's why I reach out to professionals who know better than I do, because they are educated. I am not. So I was very pleased to get this kind of answer. He is wishing me luck with my thing, which is about possible iron deposits in glaciers at the very start, where they start to form and then get pushed downhill. About the glacier 3000, or Les Diablerets, fire on top of a mountain. I made some videos about, and I still don't know. I don't know, does anyone know, or do they know and they don't tell? What caused the fire? Because I think it would be very well possible that, due to the fact that charge accumulates on edges and peaks, and I'm not talking about like devices or whatsoever, I'm talking about geological features like mountains, valleys, water streams and such. Because every water stream which is pouring out of any mountain means that the mountain is not dead. The water stream is a circuit, and it's one very small circuit out of many which are interacting all the time, and their interactions change with the changes of the electromagnetic environment in which Earth is. And we are mostly dependent on what the sun does. We are at Space with a Live solar cycle progression. These charts on this page resemble the progress of the solar cycle. The charts are updated every month by the SWPC and the latest ISES predictions. Observed values are initially temporary values that are replaced with the final data once it is available. All the graphs on this page can be exported as JSONs. For every dataset can be toggled on or off by clicking on the corresponding description under each graph. Now, I think this is much easier to handle with a computer. But this is solar cycle 25 prediction. And the red is the predicted sunspot number, standard curves method. And I just want to point out, this hasn't changed, I don't know, since the first time I noticed, which has been many months ago. I don't know. I probably should compare these ones. I just want to point out one simple thing. So, this is supposed to be the peak of our solar cycle, which is going on, number 25. And I try to draw a straight line. And this red line is the sunspot prediction number. This is solar cycle 24. solar cycle 23, which had almost 250 spots, and then it had another spike. If you follow this curve here upwards to where we reach the peak of our solar cycle this time, I think we will witness many more sunspots than they previously estimated, probably. Because it's hard to calculate, or like at least with the stuff I have, to where these two lines meet, to where is the point where this line and this line meet, how high up it will go. With this being said, the sun is ramping up, obviously. So does Earth, because we are constantly connected to the sun. That's why I think the Glacier 3000 fire could be due to geologically and atmospherically induced currents. They just choose the system of the station so much up that something fried and it catched fire. Because if you think about it, that's a mountain and that's the valley. Here's one station, here's the other station. And there's a wire between that. Many wires, metal wires, they are really thick. They are thick like your arm or leg even. So there is quite much of metal and stuff there exposed. And if the glacier up there, if there is iron inside the glacier, you can only imagine what it could do with electromagnetic environmental changes. If there's no iron, it doesn't really matter, because I still want to know what this brown or red stuff is within the ice at the point where the glacier starts to form. If it's algae, they need vitamin B12, which is the most complex vitamin. And it is used in creating or like maintaining blood and stuff. And we know we have iron in our blood. So the vitamin which the algae needs, which could be found in ice, has, at the end, something to do with iron, and even with us, our blood. And it's an algae which is growing in ice and glaciers, in Antarctica and wherever. There's just one glacier thing or ice patch in the Antarctica which is totally red. I think it's the same algae. And I think it's no coincidence that it's red. Iron ore is red too. But anyway, check out Mars, Dave Talbot, Ralph Jurgens, Walt Thornhill's, and many others' thoughts about things about Mars, Earth, our history, the influence of electromagnetics in the creation of our environment, which, of course, expands as far as we can think. We are part of the universe. We are not just only part of your village society or family or whatever. No, that's all one thing. Everything. Our solar system is just one little, very little speck in our galaxy, which is on its own just one of billions and billions and billions of galaxies, star clusters, and all these kinds of things. But anyway, I'll leave it here. Thanks.